Hey guys, so this is chapter 10, section 1. This is kind of an overview of radioactivity. Okay, so when we think of radiation, we tend to think that it's bad. We tend to have this negative view in our mind. But there's actually radiation all around us. Radiation is very common. The light in this room, the light on your screen, the radio that you listen to in the car, all of that they're forms of radiation. But basically, there are two types. So if you look at the left side of the electromagnetic spectrum, that's non-ionizing radiation. It's not dangerous. If you look at the right side of your screen, so ultraviolet over, that's ionizing radiation. That is the dangerous radiation. If you recall, an ion is an atom that has a different number of electrons. So ionizing radiation can potentially change atoms, which changes our cells, which is why it's so dangerous. So the main difference in all of these types of radiation, if you look at the scale, is the wavelength and the frequency, so how fast the radiation moves. So ionizing radiation obviously has a much higher frequency, so much more dangerous. So here's where your blanks start. So you can start filling in your blanks. If you need to pause this, you can. But so when we talk about radioactivity is dangerous. This is when we talk about ionizing radiation. So radioactivity is the process in which an unstable atomic nucleus emits charged particles and energy. And we're going to talk about there's different types of ionizing radiation, and we're going to talk about those in a minute. But radioactivity deals with ionizing radiation. A radioisotope is one of these atoms that have an unstable nucleus. So a radioisotope is just a particle that is emitting some sort of radiation. Okay. Every time you hear isotope, remember it has a different number of neutrons than the standard form. A radioisotope is going to be an isotope that emits that dangerous radiation, the ionizing radiation. But there's also safe isotopes all around us, like carbon-12 and oxygen-16. So there are radioisotopes, which are dangerous, and then regular isotopes, which aren't. So there are three types of nuclear radiation. They're alpha, beta, and gamma. We're going to talk about alpha first. Alpha is the least dangerous. It travels the slowest. It's easily stopped. That little symbol at the top, that's alpha. And just this also goes with radioactivity. Nuclear radiation refers to the actual particles and the energy that come off of one of those ionizing radiation particles or radioisotopes. So nuclear radiation, obviously dangerous. So alpha, if you remember when we talked about Rutherford, he bombarded the gold foil with alpha particles. Alpha particles are positive. And if you look over to the right of this equation that you need to fill in, that helium that has a 4 at the top and 2 at the bottom, that is an actual alpha particle. So an alpha particle has, it's made up of 2 protons and 2 neutrons. Because of that, it has a charge of +2, because remember, neutrons have no charge. So it's basically the same as the helium nucleus. It's that positive charge of the center of the helium. Alpha radiation is very easily stopped. You can stop it with a piece of paper and protect yourself from alpha radiation. Also, to be affected by alpha radiation, you'd have to be in very close proximity with it. So it's the least dangerous type of radiation. So the next type of radiation is beta radiation. This is a little bit more dangerous. Beta radiation has to be stopped by a sheet of metal or a sheet of foil. So it would totally pass through a sheet of paper. Also travels a little bit farther. Beta radiation is an electron particle. It's a negative particle that is emitted. So if you look at this E to the right, that stands for electron, and the 0 at the top, it has no mass number. Remember, electrons are super duper tiny, but it does have a charge of -1. So that is a beta particle. So the last 2 types of radiation that we just talked about, alpha and beta, those refer to particles that are emitted. It's actually, they have mass, and it's something that's emitted. There's also energy that is emitted from radioisotopes. This is what's so dangerous, because energy, just like light and X-rays, it travels at the speed of light. So energy reaches the things around it very quickly, and this is what's really dangerous. So the last type of radiation is gamma, that weird Y at the top, that's the symbol for gamma. And this is the most penetrating type of energy and type of radiation. This is what you should be afraid of. So this is also what, if you remember what the Hulk was changed with, that's not really a thing, but gamma radiation is what they talk about in the movie. So if you look, when you have a radioisotope decay in this equation, this is thorium decaying, and you can see that it releases a beta particle, it releases beta radiation, but it also releases gamma radiation. To stop gamma radiation, you need to have several centimeters of lead or concrete to stop it, and the further you get away from this radiation, the better. Here's a diagram that summarizes what you need to know, or a big chunk of what you need to know about the different types of radiation. So you can see alpha can be stopped with a sheet of paper. Beta, while will go big radiation will go through paper, it can be stopped by a thin sheet of foil. And then gamma, as you can see, is the most dangerous. It goes the furthest, and you actually need lead. When you get an X-ray, that's why they lay a lead sheet over you, because certain types of radiation can pass through certain areas. Now, small amounts of X-rays, not dangerous. We have to get them to stay healthy, but that is why we take precautions like laying a lead apron over your reproductive organs. So there's a thing called background radiation, and background radiation, it just naturally occurs around us. So it comes from different minerals that are in the ground. It comes from the air. It comes from our soil. We even give off a little bit of radiation. It also comes from space. Lots of cosmic rays bring radiation to our Earth. So background radiation, the levels are really low. They're considered safe. But just know that there's always a little bit of radiation around us. If you've done the Geiger counter experiment or you're about to do it, you'll see that when you turn on that Geiger counter, the numbers will go up a little bit. That's just minimal background radiation that can be detected. Too much radiation, obviously, or too much exposure, once again, ionizing radiation, it's dangerous. So just to remind you, radiation, it's that energy that's emitted. Ionizing radiation, this is the radiation that's dangerous. This is the radiation that can remove electrons from an atom. And when they do that, they cause the atom to become an ion. They cause it to become charged or ionized. This is why sometimes they refer to things that are highly radioactive as hot, because they're dangerous. They have ionizing radiation coming off of them. So once again, if you look at ultraviolet and X-rays and gamma rays and cosmic rays, this is the dangerous type of radiation. And then you guys hopefully know by now that visible light doesn't hurt us. So visible light over to the left, that's the type of radiation that's not considered dangerous. So how do we detect radiation? We use a Geiger counter, which is a gas-filled tube, and you're going to get to see one today that actually absorbs that radiation. When that radiation gets into that tube, it ionizes the gas inside and then causes it to make a little noise, or it will show up on the screen with how much radiation is in that area or coming out of that substance. So radiation is most commonly measured in sieverts or millisieverts, and this just gives you an idea of the different amounts of radiation and how it can affect people. Kind of interesting to see. So there are lots of people who have to work around radiation as their job, people who work at nuclear power plants, people who are X-ray techs. So they will wear a device called a film badge. This is another way, other than a Geiger counter, to detect radiation. And radiation will actually develop film. Back in the olden days when I was a kid, we had cameras with actual film that had 35 millimeter film, and that's how you would take a picture, and you didn't know immediately if your picture came out good or not. You'd have to actually get them developed. But ionizing radiation will develop that film, the same film that they used in cameras. And so they'll wear this badge, and over time, they'll be able to tell how much radiation exposure they've had at their particular job. So pause this audio for a second, see if you can answer these. Go back and look at the notes you've taken so far and see how much you remember from what I've talked about today. All right, so number one is D. Atomic nucleus, when it decays, it is an unstable nucleus that emits charged particles and energy. Remember, the particles are alpha and beta, and then the energy is gamma. Number two is D. An alpha particle is a helium nucleus that has a charge of +2. It's a positive particle. Number three is C. Alpha, beta, and gamma. And number four is A. So nuclear radiation is dangerous for us because it ionizes the atoms in our cells. It actually starts to break down the atoms that make up our cells. All right, great job. On to the next station.